All right, so today we got section 4.3, the chain rule. So we've already talked about product rule, quotient rule, power rule. So now we're going to talk about the chain rule, which gives us a different way of seeing things. So with the chain rule, basically way we want to kind of go about it is think about like a composition of functions. So f composed of g of x means that f of x is the outside function, g of x is the inside function. In order to find f composed of g of x, we need to substitute our function g of x into our function f of x everywhere for wherever there's an x at. Note, this only holds for all x values that are in the domain of g of x, and the values of g of x must be in the domain of f of x. So we're going to start out by doing the non-calculus piece of stuff, identifying inside, outside functions, forming composite functions, and then we're going to build up to doing the calculus process here. So the first thing we have is to do f composed of g of x. So that is as simple as 5 times 4x all squared plus 8, which we would have 5 times 16x squared plus 8, which gives us 80x squared plus 8 as our answer here. We could also do it the other way. We could do g composed of f of x. So 4 times 5x squared plus 8, which gives us 20x squared plus 32. Notice these two values are not the same thing, and in fact, almost always, if not always, they will be different values. They could be the same. No worries if they are. It tells us a little something special if we wanted to dig further into the algebra of it. So again, f of x is equal to square root of x minus 5. G of x is equal to 4x squared plus 6. We're going to do f composed of g. So that's the square root of 4x squared plus 6 minus 5, which is the square root of 4x squared plus 1 as our answer here. If we do this the other way, though, we get 4 times the square root of x minus 5 all squared plus 6. And when we square our square root, that disappears. So we get 4 times x minus 5 plus 6, which is 4x minus 20 plus 6, or 4x minus 14 as our answer here. So we're just showing we can do this in different ways. Now, on this next one, we're given a little bit different. So the first one we're saying is find g of 2. So g of 2 is actually 3 times 2 plus 10, which is 16. So g of 2 is now 16. So really this is saying find f of 16, which is 7 times 16 squared minus 16, which if we pull up our calculator, 16 squared is 256 times 7 is 1792 minus 16. So we get a beautiful year, if we think about that, of 1776. Now, in terms of f of k, g of f of k just means that everywhere there was an x, we're going to plug in k. So this is going to be 3 times 7k squared minus k plus 10, which would simplify to 21k squared minus 3k plus 10 as our answer here. So that's if we know f and g and we're trying to find g of f of x or f of g of x. Now, what if we're given the composite function f composed of g of x? So g of x was plugged into f of x as an inside function, and we're wanting to find f and g. So our outside function here could be square root of x, and g of x would be 4 plus 5x squared, if we just look at inside versus outside. Same thing on the next one. We could have our entire function could be a fraction of 1 over x, and g of x could be x squared minus 2. There's multiple ways we could do these to define f and g. These are just some of the most common style that we're going to see. Now, that was all the non-calculus pieces. That was finding f of x and g of x, finding f composed of g of f of x and g composed of f of x. Now we want to actually do the derivatives of using the chain rule. So if we have any function y equals f composed of g of x, then to take its derivative, this is going to be f prime of g of x, so the derivative of the outside, times the derivative of g of x, g prime of x, which is the inside. So if we think about this, this is the derivative of outside times the derivative of inside. So let's look to see how that works. Y equals 7x plus 3 all raised to the 5th. So y prime is equal to, the derivative of the outside would be 5 times 7x plus 3 to the 4th. That is the f prime of g of x. Now we're going to multiply by the derivative of the inside, which is just 7. So then simplifying, we get 35 times 7x plus 3 raised to the 4th. Now for this one over here, f of x equals square root of 5x minus 1. First, let's rewrite this as 5x minus 1 to the 1/2. Makes it a little bit easier to see that when we take its derivative, we get 1/2 times 5x minus 1 to the negative 1/2 times the derivative of the inside, which is 5. So if we simplify this, we get 5 divided by 2 times the square root of 5x minus 1. So on this next problem, we're told find the slope of the tangent line at x equals 2. So before we can find any of this, we have to take its derivative. So y prime equals 1/4 times x to the negative 2 plus x to the negative 3/4 times the derivative of the inside, which is minus 2x to the negative 3rd plus 1. If we were to simplify this, we would get minus 2x to the negative 3rd plus 1 over 4 times x to the negative 2 plus x raised to the 3/4. At this point right here, we want to go ahead and plug in 2 into our x value. So negative 2 times 2 to the negative 3rd plus 1 over 4 times, sorry, not negative, 4 times 2 to the negative 2 plus 2 all raised to the 3/4. So we have negative 2 over 8 plus 1 over 4 times 1/4 plus 2 to the 3/4. So negative 2 over 8 is negative 1/4 plus 1 gives me 3/4 divided by 4 times 9/4 to the 3/4. Or 3 over 16 times 9 over 4 to the 3/4. I'd probably leave it there. I'd pull up a calculator to see what it would give me. So when we do that, we get, if we round this to 4 decimal places, this is approximately 0.1021. If we plug that into our calculator. Not something that really gives us a whole lot of information or anything, so therefore it would be fine. To not have to worry about that. So for on these two, we're just finding the derivatives. So for this one, we have a product rule. So y prime equals the derivative. The first one is just 1. So times the square root of x squared plus 3 plus x times the derivative here is 1/2 times x squared plus 3. So the negative 1/2 times 2x. So we have the square root of x squared plus 3 plus x squared over the square root of x squared plus 3. If we got a common denominator here of square root of x squared plus 3, we would have x squared plus 3 plus x squared. That is simply by taking and multiplying this by the square root of x squared plus 3 over itself to get a common denominator. And so we end up with 2x squared plus 3 all over the square root of x squared plus 3. If we rewrite this one, 2 divided by 2x minus 3 to the third, we would have 2 times 2x minus 3 to the negative third. Then we could take its derivative to get minus 6 times 2x minus 3 to the minus fourth times 2, or negative 12 over 2x minus 3 to the fourth. So we can see the chain rule in different ways. It's just a matter of seeing what we're given and being able to compare it to that. So the next thing we could do is we could be given a chart. So it says find d sub x, so the derivative with respect to x, of f composed of g of x, and vice versa, the derivative with respect to x of g composed of f of x at 2. So if we use the formula that d sub x of f of g of x is equal to f prime of g of x times g prime of x, what we're really trying to figure out here is we need to find both of these. So if we do the first one, f composed of d of x, so d sub x of f composed of g of x. So, and this is f prime of g of x times g prime of x. Well, we're told use this at x equals 2. So this is f prime of g of 2 times g prime of 2. Well, g of 2, so here's my x of 2. So g of 2 is 3. So this becomes f prime of 3 times g prime of 2 is 3 over 7. F prime of 3 is negative 8. So negative 8 times 3 over 7 gives us negative 24 over 7. Well, it also said do this in a similar way. It wants us to do the same thing for g. So d sub x of g composed of f of x at 2 would be g prime at f of 2 times f prime at 2. So f of 2 is 4. So we get g prime at 4 because f of 2 is 4. F prime of 2 is negative 7. G prime at 4 is 5 over 7. So 5 over 7 times -7 gives me -5 as our answer. So for a separate problem, it says find f prime of x of f of x equals x times 6x plus 1 to the 4/3. So that tells us f prime of x is equal to we got a product rule. Derivative of x is 1 times 6x plus 1 to the 4/3 plus our x times the derivative of the second one would be 4/3 times 6x plus 1 to the 1/3 times 6, or 6x plus 1 to the 4/3 plus 8x times 6x plus 1 to the 1/3. We could do some algebra here. We could factor out a common factor of 6x plus 1 to the 1/3, and then have that times 6x plus 1 plus 8x. So we could have 6x plus 1 to the 1/3 times 14x plus 1. So we were then told for that same problem, find the slope of the equation line at x equals 2. So f prime at 2 is 6 times 2 plus 1 to the 1/3 times 14 times 2 plus 1. So we would have 13 to the 1/3 times 29. If we approximate this to a few decimal places here, we get approximately 68.19, because it says we need the tangent line, so that means that we need to plug in 2. So f of 2 is 2 times 13 to the 4/3, which is approximately 61.13. So we have a slope and a point. So we have y minus 61.13 equals 68.19 times x minus 2. Means y equals 68.19x minus 136.38 plus 61.13, or y equals 68.19x minus 74.767 would be our tangent line. So sometimes these numbers get ugly, sometimes they're not. So it just all depends on what we're given, depends on if they're going to be ugly or not.